Hello.
Good evening, doctor.
Good evening, doctor.
My name is Foong Shien, Foong Shien, and my metric number is 187113.
Okay, my name is Aina Sahira binti Zainal Azlan, and my matrix number is 187230.
So today experiment, we have two parts. We're going to do dissection of frog. I'm going to dissect a frog.
Okay, for the second part, I'm going to observe the slide of muscle tissue. Okay, now let's begin.
So basically, this is a frog. The body of the frog can be divided into two parts, the head region and the trunk. So we look at the head first. We can see this, a frog consists of a pair of tympanic membrane, eardrums. This is to allow the frog to detect the high pitch of sound. Then we look at the eyes of the frog. The eyelid, frog has three eyelids. This is the upper eyelid, lower eyelid, and this is a transparent nictitating membrane. This membrane is to protect the eyes from drying. So now we're gonna to open the mouth to observe the external anatomy of the mouth. So we have to open it. This is the tongue of the mouth to capture the prey. And this is the jaw of the frogs, and you can see these small structures along the upper jaw. This is called the maxillary teeth. Then this a pair of hole is the internal nerve. And you can see this, the two little structures. This is marine teeth at the roof of the mouth at the rear end with the V shape. And this two is the eustachian tube, is to equalize the pressure in the frog. Is located at the angle of the jaw. We have the glottis, the airway which leads to the lung for a gas exchange. It's located behind the tongue. Here. This is the male frog. So
Vocal sac opening.
this is the vocal sac of the frog.
Vocal sac opening.
The vocal sac opening. Here. You see it? Small hole. A pair of vocal sac here also we have. So now we're moving on to the trunk region. It has two pairs of appendages. These two pairs of front legs and the pairs of hind leg. So we see here. The front leg we have the 4 digit, and for the hind leg it have 5 digit.
Web.
And the behind of this have the webbing membrane to propel the animal in the water for swimming swimming purpose. Sure. And this is the coraca region, is to remove the undigested food such as urine, eggs, and sperms. Basically, the textures of the skin is smooth and moist, and it lacks of scale or hair. The gland in the skin secrete mucus to help it keep moist for the gas exchange and respiration. Going to pin it to fix it in place before we dissect it. So we pin in. Raise the skin with a pair of forceps, then make a small incision in the skin. the inner surface of the skin have numerous inconspicuous line. This is the small blood vessel, the vein or arteries in the skin. After recutting the skin of the frog, we can obviously observe the muscle of the frog. So this is the ventral view of the muscle system of the frog. This is the rectus abdominis. This muscle extends lengthwise on other side of the ventral median white line. Its origin on the pubis and its insertion is dorsal on the sternum and the coracoid. Its action is to compress the abdomen and depress the sternum and coracoid. And this is the external oblique.
Yes.
It is made up of the thin sheet of posterior ventrally extending fibers on the either side of the body. Its origin is dorsal fascia. Its insertion is linea alba dorsal to rectus abdominis, and its action is to compress abdomen and aids in expelling air from the lungs. So view, we can see the dispressor mandibulae and the dispressor mandibulae and the temporalis. Muscle on the dorsal surface, we have the dorsalis scapulae. This muscle is behind the tympanic ring and the dispressor mandibulae. And this is lower below the dorsalis is the latissimus dorsi, a wide muscle just posterior to the dorsalis scapulae. And this is a longissimus dorsi. This is a narrow tapering muscle which parallel to the vertebrae column. Its origin is anterior portion of the urostyle, and it acts to elevate the head and strengthen the face. The pectoralis muscle, it can found on either side of the ventral surface. The front leg, it has several types of muscle as well. This is the deltoid. This is the prominent muscle on the anterior border of the upper arms, and this is the lower. It has the tricep, branchies. It is a larger muscle on the dorsal surface of the upper arms. It is act as the extensor of the front legs. And this is the bicep. It is the same muscle as tricep branchies, homologous to bicep of the upper arms in higher vertebrae. Hind legs, it has the rectus and thicus. This is rectus and thicus. This is the large bulging muscle visible on the dorsal surface along the median. It extends to the foot and flexes the shank. Okay. Muscle of the shank. This too is gastrocnemius, the larger bulging muscle visible on the surface along the median border of the shank. It extends the foot and flexes of the shank. Okay. Dissect the frog to observe the internal anatomy of the frog. So it's the same method as we cut the skin.
Cut the muscle.
Muscle je. Lembut je. Lagi kan?
Baik, jangan potong dalam dia.
Tak. the internal part of the frog. This is at the anterior part. It is the heart. It's a 3-chamber heart. It's still pumping, so it's responsible for the circulatory system. And this 3 lobe is the liver, the large portion of the organs in the body cavity. So beneath the liver we have the gallbladder. This is the gallbladder, and also we have the lungs here for respiratory system. It has a pair of lungs. Another is here. This is the stomach for the storage of the food. Involved in digestive system. Then this is the spleen. Spleen, the small red color. This is the intestine, small intestine. The absorption of the nutrient mainly occur in the intestine. This is the large intestine. Absorption of water occurs here. This is the urinary bladder of the frogs. So it's like fulfilled with what we call it, occupied with urine. So this frog have never been tested. Last we have the small white color. This is the intestine of the frog. So this frog is a male frog. Okay. So beneath the large intestine we have this kidney, like the dorsal vessel, and the beneath of the kidney is the spinal cord of the frogs. So this is the fat bodies of the frogs. So that's all. The urinary bladder and the large intestine connected to the cloaca. To later on it will remove those waste out of the body.
Okay.
After we have observed the internal part, now we look at the brain of the frog. So we cut the head down, so we like this. Then we can look at the white color. This is the brain of the frog. It's involved in the nervous system. Okay.
Okay, this is smooth muscle tissue. When observed under microscope with 40 times magnification, smooth muscle fibers are small and tapered, with the ends reducing in size, in contrast to the cylindrical shape of skeletal muscle. A smooth muscle tissue fiber has a single centrally located nucleus. Okay, the function of smooth muscle is to constrict the vessels they surround. Smooth muscle also contributes to moving fluid through the body and to the elimination of indigestible matter from the gastrointestinal system. Okay, you can found this type of tissue lining the walls of hollow internal structures such as blood vessels, stomach, intestine, gallbladder, urinary bladder, and airways to the lung. Okay, this is skeletal muscle tissue. When observed under a microscope with 40 times magnification. Okay, skeletal muscle is called striated because of its appearance consisting of light and dark bands visible using light microscope. Okay, as you can see, a single skeletal muscle cell is long and approximately cylindrical in shape, with many nuclei located at the edges, which is periphery of the cells. Okay, the function of this tissue is basically for movement of the skeleton and movement of tissue. Okay, the next tissue is cardiac muscle tissue. Cardiac muscle fibers are striated, branched, sometimes described as Y-shaped, and have a single central nucleus. These fibers are attached at their ends to adjoining fibers by thick plasma membranes called intercalated discs. Okay, basically the function of this tissue is the pumping of blood through the heart. This type of muscle tissue only can be found in the walls of heart. Okay, this is the slide which we can observe the intercalated discs of the cardiac muscle tissue. Okay, intercalated discs are microscopic identifying features of cardiac muscle. Cardiac muscle consists of individual heart muscle cells connected by intercalated discs to work as a functional organ or syncytium. Okay, the function of the intercalated disc is to support synchronized contraction of cardiac tissue. Okay, the last slide that we are going to observe is to observe the striated muscle of the cardiac muscle tissue. Okay, striated muscle is a muscle tissue that features repeating functional units called sarcomeres, in contrast with smooth muscle tissue.
All for today's experiment. Bye.